This question focuses on how to handle a common problem in machine learning. Datasets where one class has far more examples than another. I'm specifically looking at how to improve the model's ability to correctly identify the less frequent class in logistic regression. We have a dataset where 95% of the data belongs to one class, class 0, and only 5% to the other, class 1. This is a significant imbalance. And it can cause problems because the model might become biased toward the majority class and fail to predict the minority class accurately. I need to find strategies to mitigate this. The core question is, how can I improve my model's ability to correctly predict the minority class, class 1? I'll look at several techniques related to the *LogisticRegressionCV model in scikit-learn. Increasing *C's reduces regularization, making the model more complex. A more complex model might overfit to the majority class, making the imbalance problem worse. I'll avoid this option. *C's is a list of regularization strength values. C, the inverse of regularization strength. Decreasing *C's increases regularization, simplifying the model. This might prevent the model from overfitting to the majority class and improve performance on the minority class. I think this is worth investigating further. Setting *class_weight equals balanced automatically adjusts the class weights. It gives the minority class more weight during training, helping the model pay attention to it. This directly tackles the class imbalance issue. Increasing *CV the number of cross-validation folds, improves the reliability of hyperparameter tuning. It doesn't directly address the class imbalance, but better tuning can lead to overall better performance. This will give a more robust model. *CV refers to the number of folds used in k-fold cross-validation. I'm tackling a common machine learning problem, class imbalance. That means one class in my dataset has way more examples than another. In this case, LogisticRegressionCV is my chosen algorithm, but because of this imbalance, I'm looking at ways to make sure the model doesn't ignore the minority class. We'll explore strategies to improve the model's ability to correctly identify the underrepresented group. It can directly address the class imbalance problem by using the *class_weight equals balanced parameter. This tells LogisticRegressionCV to automatically adjust the weights given to each class during training. The minority class gets a bigger weight, ensuring the model pays it more attention. This is a super effective approach. Let's talk about regularization, controlled by *C's. Lower values of *C's mean more regularization, leading to a simpler model. With imbalanced data, a simpler model is often better because it's less likely to overfit to the majority class and ignore the minority class. Think of it as preventing the model from becoming too focused on the large number of majority class examples. Increasing *CV increases the number of times I split my data for cross-validation. It makes my model evaluation more reliable, so I'm more confident in choosing the best hyperparameters. While it doesn't directly address the class imbalance, it results in a more robust and reliable model. That's a great side effect. This phrase highlights the core challenge. We're dealing with a dataset where one class, the minority class, is vastly underrepresented compared to the other, the majority class. This imbalance can severely skew the performance of our model if left unaddressed. I need to find strategies to help my model recognize the minority class better. I'm using a specific type of logistic regression in scikit-learn, a popular machine learning library in Python. LogisticRegressionCV automatically tunes the regularization strength, how much the model is penalized for complexity. The goal is to build a model that accurately identifies the smaller class, which represents only 5% of our data. I need to select strategies that will address the class imbalance I've described above. This is a powerful setting. I can instruct LogisticRegressionCV to automatically adjust the weights assigned to each class during training. The minority class will receive a higher weight. Think of it like this: I'm giving the model extra emphasis on correctly classifying those less frequent cases. Here, *CV refers to the number of cross-validation folds. I'm essentially splitting my data into multiple parts and training my model on different subsets. By increasing CV, I obtain more reliable estimates of the model's performance. This helps ensure that I'm choosing the best settings, hyperparameters, for my model based on robust evaluation. Although it doesn't directly address the class imbalance, more reliable evaluation will indirectly aid model performance. C's controls the regularization strength. A smaller C's value means more regularization, forcing the model to be simpler. With a highly imbalanced dataset, a simpler model is less likely to overfit to the majority class and therefore will be better at identifying the minority class. It's like preventing my model from paying too much attention to the abundant majority class. This simply shows that the main problem is the significant difference in the number of instances of class 0 versus class 1. This disproportionate data distribution could lead to a model that mostly learns the patterns in the majority class, neglecting the minority class. I'm tackling a common machine learning challenge, building a logistic regression model with a dataset where one class has far more examples than another. That's class imbalance. We'll explore how to handle this using LogisticRegressionCV from scikit-learn. It's a powerful tool but needs careful handling with imbalanced data. Specifically, I have a binary classification problem. The data is severely imbalanced, with a huge disparity between the number of examples in class 0, 95%, and class 1, 5%. This imbalance can cause problems. It may cause our model to ignore the important minority class, class 1. My goal is to find ways to improve the model's accuracy in predicting this less frequent class. I want to select the strategies from several options that will help my logistic regression model better predict the minority class. I'll explore how adjustments to the model's parameters will address this class imbalance issue. Increasing Cs means less regularization. A less regularized model is more complex and can potentially overfit to the majority class, ignoring the minority class. This would make our problem worse. So, I'd avoid this. I'll try decreasing Cs. This increases regularization, making the model simpler. A simpler model is less likely to overfit, which is great for imbalanced datasets. This should help me pay more attention to the minority class and obtain better predictions. Setting directly tackles the class imbalance. This clever technique automatically assigns weights to classes based on their frequency, giving the minority class more importance during training. This is a powerful tool to handle class imbalance problems. I expect this will significantly improve the performance on the minority class. I'll increase the number of cross-validation folds, represented by CV. Cross-validation gives a more robust estimate of model performance. A higher value of CV doesn't solve the imbalance directly but provides a more reliable way to choose the best model parameters, indirectly improving prediction of the minority class. It's a valuable step in building reliable models, even if it doesn't address the class imbalance head-on. This problem focuses on how to handle imbalanced datasets, specifically in logistic regression models. I'm dealing with a situation where one class has far more examples than the other, which can throw off the model's ability to learn properly. The goal is to find strategies to improve the classification of the less frequent class. I'll use the class_weight equals balanced parameter. This tells the LogisticRegressionCV function to automatically adjust the weights given to each class during training. It inversely weights classes based on their frequency, giving more weight to the less frequent class. That way, I help the model pay more attention to the minority class, making it better at classifying those examples. I'll decrease the C's value. C's controls the regularization strength in logistic regression. A smaller C's means more regularization. This simplifies the model and reduces its tendency to overfit the data. In an imbalanced dataset, a complex model, less regularization, might overfit to the abundant majority class and perform poorly on the minority. By decreasing C's I aim to improve generalization to the minority class. Think of it as making the model less picky. I'll increase CV. CV stands for cross-validation. It's a technique to estimate the model's performance more reliably. A larger CV value, more folds, means a more robust estimate. While this doesn't directly address the class imbalance, a more accurate assessment will lead to better hyperparameter tuning, potentially improving performance on the minority class. It's like getting more opinions before making a big decision. I'll avoid increasing C's . Increasing C's reduces regularization, leading to a more complex model prone to overfitting. In this case, that means the model might become even more biased towards the majority class. I want to prevent this from happening and improve the minority class classification. Core of the problem. I'm looking at how to improve a model's performance on the smaller class in an imbalanced dataset. I'm working with a highly imbalanced dataset where class 0 makes up 95% of examples, and class 1 makes up only 5%. This imbalance affects model training and negatively impacts the model's ability to accurately classify the rare cases. I'm tackling a common machine learning challenge, class imbalance. In this case, we have a significantly larger number of samples belonging to one class, the majority class, than the other, the minority class. This can cause problems because our model might get too focused on the majority class and ignore the minority class, leading to poor predictions for the minority class. We need to find strategies to counter this imbalance. This problem involves improving logistic regression's performance with an imbalanced dataset. We have a dataset where 95% of the data points belong to class 0, and only 5% belong to class 1. That's a serious imbalance. This means the model could easily learn to predict class 0 most of the time and ignore class 1, resulting in a model that is not very useful for identifying the important minority class. I need to think carefully about how to deal with this class imbalance. I'm looking for techniques to help my model do a better job of identifying the minority class, class 1. The goal is to create a model that's both accurate and fair to both classes, not biased towards the majority class. The question focuses on techniques that can improve the prediction of the less frequent class. Increasing C's means less regularization. This can lead to a more complex model, which might overfit to the majority class, making it even harder to correctly classify the minority class. I would avoid this approach in this scenario. Think of it like trying to fit a very detailed curve through data points. You might get a great fit for the majority, but it would not generalize well to minority data points. Decreasing C's increases regularization and simplifies the model. This will help the model avoid overfitting to the majority class. The simpler model will generalize better to the minority class data points, improving predictions. This approach creates a more general model which is less likely to be biased. Setting class_weight equals balanced directly addresses the class imbalance problem. This tells the model to give more importance to the minority class during training. By adjusting the weights, I'm explicitly telling the algorithm to pay more attention to class 1, reducing bias towards class 0. It's a really straightforward solution to handle class imbalance. Increasing the number of cross-validation folds improves the reliability of the model evaluation, not directly addressing the class imbalance. It's a good strategy for getting more robust and reliable results but doesn't specifically solve the class imbalance. While not directly addressing imbalance, it ensures that hyperparameter tuning is more robust.